Good afternoon, everyone. Today we're doing section 11.1, and this is where we're going to look at the difference between two proportions. We'll do a hypothesis test about the difference between two proportions. We'll even do a confidence interval, about that difference between two proportions. So this is the ending portion of our course, is chapter 11, where we're actually looking at different proportions. Next class we'll look at different sample sizes in terms of their means. So all this is inferential statistics. So what we're doing here is inferences about two proportions. You can always say that word, inferences. I mean, the author's title of this book, Inference About Two Population Proportions. So this is inferential statistics, but where we start is we get these samples. And that's why they have those hats on, okay? This thing does look overwhelming when you see it at first. I know that sample test statistic there that we're going to find. You're like, my gosh, good golly. So we'll use the technology absolutely to facilitate this. But if you wanted to do everything by hand, absolutely you can do that and do that. There's something new though we're doing here because we have two proportions. See this over here? This is called a pooled statistic right there. That right there. We've got, you see, we're going to have two different proportions. For a proportion 1, group 1, say it's the control group. All right, that has a subscript of 1. And then group 2, let's say that's the experimental group, right? They get the medicine, the real medicine. Remember we talked about that in class. Control group gets like a placebo, right? Well, this right here in the math formula, they just pull it together, like putting everyone in a swimming pool. So they pull it together. It's a pooled statistic where p hat's just, you add the x's in both populations and you divide by the two sample sizes. So I just want to point that out because you're probably looking here going, where's the subscripts? Where's the sub 1 or sub 2? Which group is this from? It's a pooled statistic right there. So that's what it's called. But the technology will put all this together for you. So absolutely, please feel free to use that to facilitate the computations. What's important to us is, being able to analyze this stuff, interpret things. It's going to be everything the same, everyone. So it's going to it should run smoothly. Like from that last test on chapters 9 and 10 with a p-value. If your p-value is low, what do you do about the hoe? Reject the hoe. I mean, it's the same thing. So that's what's awesome about this stuff. I did want to give you a couple copies so you can look at, different ways people wrote explanations on the last tests. So if you missed something, you're like, wait, why did I get this wrong? What am I not saying in terms of creating a conclusion to a test? There is evidence or there isn't evidence. I do want to point out we're going to set this stuff up very similarly. It's going to be a similar way that we set these up. You will have two different proportions. So when we set this stuff up, we set up our hypothesis test, there's going to be two proportions. Population proportion 1 and population proportion 2. If these subscripts of 1 and 2 bug you, I've seen students before call this like group 1. Population for group 2. I've written it like that. But we're talking about two different proportions here. So we just give them subscripts. Not bad. Well, what's the null? That there's no difference. So for every one of these problems, that'll be our null hypothesis. Then, proportion 1 is equal to proportion 2. No difference. So that's always going to be our null hypothesis in this entire section. Hey, but you might have a left tail test. And you know what we'll do? What symbol do you think? It's like, do we draw two different bells? Nope. If you're thinking this is going to be confusing, absolutely not. We're still going to have this one normal distribution. We're talking about just the difference between these two. And left-tailed, you'd shade where? Over off the left side, right? How much? Well, they have to give you that level of significance. True? 5% level of significance or 1%. What would it be if this was right-tailed? Right here you get this. Right down. We'll see when we read the problem what we have. I'll get this out of the way. Here. And what's the last one?
It's different or changed.
Yeah, so when we read the word problems on the book, we can kind of say something. Is it different? Is the difference different? Has it changed? we will do a two-tailed test. We'll have to take that alpha level, that level of significance, and divide by 2. So this would be all for these, but what would be the null every time? No matter what. I'm not putting hats on these, because we're talking about inferential statistics. We're talking about the population proportions. So I just want to point that out. That's how you'll set it up in this section when you're doing your hypothesis test.
I got a question.
Sure.
So since P1 equals to P2, so that means you're saying like when you have to take a sample, so if you take like 1,000 people for control group, the 1,000 people should be on the experimental group too? Is that what?
That's it.
That's it?
That's exactly it.
Okay.
So, all right, very good. And the problem we're going to start with is in page 540, it's number 20. So if you have your book, feel free to read along with me. It's on page 540. It's number 20. This is from section 11.1. But I'll write down all the statistics they get. They're going to look at 2 different proportions. Do you remember what a double-blind experiment meant? Yeah. Ooh, good, Randy. Yeah. Whoever's administered, double-blind experiment. It's like a drug. Neither the doctor knows, right, or the patient knows what they're getting. Am I getting a placebo, or am I getting the real thing? Those are the best experiments. They definitely, you know, the best defense against bias when you have this double-blind experiment. All right. Hey, we're going to go through the same stuff. Now, we're going to set up a hypothesis test, right? Then we'll verify our requirements, and you're like, gosh, what's the requirements going to be for this? It's not that bad. It's to remember the N, P, Q greater than or equal to 10? Mm-hmm. Same stuff. I'm seriously. The N had to be less than or equal to 5% of the population. Same stuff, so we'll be okay there. Then we'll perform our hypothesis test, when we'll state our conclusion. So that's what we'll go through, everyone. If you just want a quick, we're going to set up the hypothesis test. We'll verify our requirements. Shouldn't take too long. Then we'll perform the hypothesis test. We're going to perform it. We'll do classical and p-value approach. And then we'll state the conclusion. Okay, so we'll go through these things every time. Boom, 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 boom. And we'll start with number 20. All right, there's our sample test statistic for this section. All right, this is called the drug Prevnar. The drug Prevnar is a vaccine meant to prevent certain types of bacterial meningitis. It's typically administered to infants starting around 2 months of age in a randomized, double-blind, clinical trials of Prevnar. Infants, everyone, these are infants, were randomly divided into 2 groups. All right. Subjects in group 1 received Prevnar, while the subjects in group 2 received a control vaccine, a placebo. So we'll start with that, and when you're going to have a group 1, and there's going to be a group 2, they're getting the drug, they're getting the real treatment, they're getting the Prevnar. They're getting that drug, Prevnar. Make that really big, people see that. Whereas group 2, that's your control group. They get a placebo or control vaccine. All right. Well, what's the numbers? They went out, they did this study. All right, after the second dose, they got 2 doses. This is what they saw. 137 of 142 subjects in the experimental group experienced drowsiness as a side effect. So let me put that down over here. This is group 1. The wording from the textbook. 137 out of 452. Don't we make that a p-hat? Mm-hmm. Yeah, so when you go 137 out of 452, you can think of that as 137 out of 452. This is group 1. That's your X, that's your N. Right? That's the proportion. Experienced drowsiness as a side effect. Now, how in the world do you know an infant 2 months old is experiencing drowsiness? I have no idea. I can't answer. Hey, this is your X1, that's your N1. We just put subscripts like this. Okay, that's my P hat one. That's your P hat one, right? Well, how about the control group? How many experienced drowsiness there? 31 out of 99 subjects in the group, the control group, experienced drowsiness. Okay, over here, everyone, P hat 2, 31 out of 99. Drowsiness. Now, they didn't explain it in the study, but if some of you are curious why this is so low, and this is so high in terms of the samples, the way they distributed this, no idea, they didn't even talk about that. A lot of times they're close to each other, but it does indicate that these don't have to be really, really, really close to each other to do this study. But this was really done, so you're probably sitting there going, 99? This is 452 in terms of the sample size. That's X sub 2, that's N sub 2. X sub 2, N sub 2. All right. And we're going to read this question, then we can set up the hypothesis test. Does the evidence suggest that a lower proportion of subjects in group 1 experience drowsiness than those in group 2 at the alpha equal to 0.05 level of significance? All right, where's the yellow chalk? Put that level significance down. And then for this problem, alpha equals 0.05. That's your level significance. Read the question again. Does the evidence suggest that a lower proportion in this group experience drowsiness than this group? Okay? That's what we're running. All right, so we're going to set up this hypothesis test. Here's the setup. Null hypothesis, H sub 0, H naught. And then the alternative hypothesis, H1. What's the null? That they're both the same, right?
Yeah.
Set them equal. And don't put hats on them, these are rows. Row sub 1 equals row sub 2. The population proportion in group 1 is the same as the population proportion in group 2. In terms of drowsiness, right? Control group, just as drowsy as this group. That's our null, true? But the alternative, let me read that again, the question, we'll set it up. They go, does the evidence suggest that a lower proportion of subjects in group 1 experience drowsiness as a side effect than those in group 2? So this one has to be lower than this. How would you set that up?
Row 1 less than row 2.
I love it. I love it. I agree. Lower, this lower than that, this less than that. They said this lower than this less than that. That's probably the most important step to our whole process. We got to make sure we get that left-tailed test set correctly.
Sorry, I'm just going to back over. So
You bet.
The null hypothesis is just stating that that both groups experienced drowsiness.
That's right. You know, and we're saying not only that, that was good. They both experienced drowsiness, but the same proportion. Roughly the same proportion will be just as drowsy. It's not like we're basically saying, yeah, we get this. It's not like, oh, you take this drug, all right? It's to treat bacterial meningitis, but as a side effect, we're like, but is this going to make them really, really drowsy, right? That's what we're trying to see. And we're saying the null hypothesis is no. No, you take this drug for bacterial meningitis, you're going to be just as drowsy if you just didn't take anything. Does that make sense?
Yes.
Oh, good. So that's what we're